Let's take this a step higher for chemical engineering students. Now I have a problem that says that an air expands adiabatically in accordance with the law PV raised to 1.4 is equal to K. So if at a given time the volume is 14 cubic feet and the pressure is 40 pounds per inch squared, so that's PSI, at which rate is at which rate? I think this should be at what rate? At what rate is the pressure changing when the volume is decreasing 1 cubic feet per second? Okay, so there's a lot going on this problem, and I want to talk about this first. Now, as what I've mentioned before in optimization, if there is a problem that requires some kind of definition or laws that or principles that should be stated in the problem, then I'll be adding that on the problem. In this case, there is one, and that is typically this adiabatic expansion. Now, we know very well in your high school days that you're taught about this expansion and contraction of gases, specifically when we talk about this Boyle's law, Charles' law, Gay-Lussac's law, and all these combined gas laws. Now, there's another one, we call this the adiabatic process, wherein there is no net heat transfer between expansion. So basically, if we have a pressure and a volume, if you raise that volume to a certain degree, that's 1.4, that will always be constant. The product of that will be constant. For example, if you select a certain pressure, let's say at 40 psi, and then the equivalent volume for that would raise to 1.4 will always be constant. And that's how it works for this. The K here means that it is always constant. And the question is, what is the rate at which the pressure is changing when the volume is 1 cubic feet? When the volume is decreasing for 1 cubic feet per second. Now, in our first video, we actually do some representation to be able to solve problems. But in this case, we already know that we can actually represent that in a drawing because it's a behavior of the gases. Thus, you're not actually able to represent that in terms of a drawing. So what we'll do here is to simply go with the second step, which is evaluating that based on all the given and the general equation. Now, problems like this would almost all the problems like this would give you the general equation. And in this case, we're already given by that. This is the Adiabatic law wherein PV raised to 1.4 is equal to K. P here stands for the pressure and the volume is, V is for the volume. And doing this, we can actually directly differentiate this implicitly so that we can get the change in pressure as the volume decreases. So we should be taking the derivative of this expression with respect to time. Okay, so with this, we know that the pressure and the volume are independent variables, so they should be differentiated in a way that they're not constants. So we have P, we have product rule, so P times the derivative of V raised to 1.4, so that's simply 1.4, and then V raised to 1.4 minus 1. And then since we've differentiated V, we need to add the derivative of V, which is dV over dt. That is with respect to time. And then we add V raised to 1.4, and then the derivative of P is 1 times dP over dt. Okay, so that's implicit differentiation. And then we know for sure that if we differentiate a constant, regardless of the differentiating variable, we know that that will be equal to 0. Okay, so this is our general expression. And since we know that we're looking for the rate of the pressure change, so we need to find this dP over dt. So dP over dt is simply equal to negative 1.4 P times V raised to 0.4 and then dV over dt divided by V raised to 1.4. So I just transposed this expression to the right and then divided all by V raised to 1.4 so that I'm left with dP over dt. So let's just move this a little right here. Okay, so that's perfect. Now let's try to substitute all the values. We need dP over dt, and we already separated at the left. So dP over dt is equal to negative 1.4. And now the pressure is given here. That's 40 pounds per inch squared. Now this is 40 psi, and we know that this pounds per inch squared. Let me convert this inch squared to feet so that I match with this cubic feet right here. So we know that for every 12 inches, we have 1 foot. So we need to square that because this is in inch squared. And then we have the volume. The volume is 14 cubic feet. So that's 14 cubic feet. And then that is raised to 0.4. And then we have dV over dt. So the decrease in temperature is simply 1 cubic feet per second. Now, since it's a decrease, we could just use negative 1 cubic feet per second instead of just using 1. And then we have V raised to 1.4. So we have 14 again cubic feet. And then we raise that to 1.4. Okay. So in this case, we have dP over dt is equal to, so the answer is 576, and that is pound force per feet squared per second. So that's the unit. So this is the change in pressure. Now we know that we can cancel this inch squared, and then we're left with per feet squared. Now in this case, we also have 0.4 over 1.4, which is actually negative 1 if we subtract these two. And then with that, knowing that this is negative 1 and this one is cubic feet, the units will just cancel out, and now we're left with feet squared at the bottom of this equation. So the unit can also be represented as 576 and then pound force per feet squared second. But you can also use PSI instead. So if you would be using PSI, you can convert this pound force per feet squared. So you just have something like 576 pound force per feet squared second multiplied with for every 1 foot we have 12 inches. So we square that, so we can cancel this out. So we're left with pound force per inch squared. That's the equivalent of PSI. So you will have 4 PSI per second instead. Okay, so this is how we solve for that kind of problem. So this is the answers that you can write. They are just all the same. Okay, so the rate of change of our pressure is 576. So basically, if we're looking for this expression wherein we have a decrease in volume, but based on this expression, we could tell that the expression still remains constant when it changes with respect to time, with the pressure being positive. Okay, so not in all cases that if the volume is changing negatively, the pressure will also be changing negatively. So as you can see here, that the pressure is actually positive because of the transposition that happened right here. So I think that's all for this kind of problem, and it's fairly easy when you're given with the general equation. Now in this problem, let's try solving a hemispherical basin wherein it is filled with hexane and then it drains somewhere at the bottom of this basin. And the question is, how fast is the hexane level falling when the depth of water is 5 inches? So basically, we're looking for the change in the height or the level of this hexane. So to illustrate that, we'll be drawing a sphere, okay, or a circle. And basically, we don't actually need the top of this portion because it's a hemisphere. So if you don't know a hemisphere, so a hemisphere is half of a sphere. So basically, it looks like this one, okay? And then let's draw some, I think oval na lang siguro dito para mas magets na siya yung idea. So it looks like this, and it is kind of filled with water at first. So yun. And then we know for sure that the basin has a diameter of 20 inches. So it's already given naman kasi. So we have 20 inches for this one. So that's the diameter. That's D. And then the rate at which hexane drains is equal to 3 inches per second, cubic inches per second. Okay. And then at a depth of 5 inches. So, let's draw yung depth na yun, 5 inches. So, almost kalahati yon. Okay? So, sa lalim na yan, so that's 5 inches. Okay? Ano kaya yung rate of change ng level? So, let's just use dh over dt in this case. So, ito yung ating height from the bottom. Okay? So, you might be thinking na, it's easy, sir. The volume would be from sphere that will be 4/3 pi r cube, and then you just have to take half of that, so you will get 2/3 pi r cube. So, that is true if we're talking about the hemisphere alone. This is just the formula, but we know for sure na hindi to hemisphere lang because we're talking about a hemispherical segment or a spherical segment here, or a spherical dome. Sometimes yun yung tawag, or spherical cap. Kasi this is our concern, the volume of this portion and not the whole hemisphere. So basically, hindi natin pwede gamitin yung hemisphere na formula because hindi naman ito yung tinutukoy natin na radius eh. In this case, nabawasan na yung ating distance from the radius itself. So, hindi natin pwede sabihin na yun na yung ating gagamitin na formula. So, there are two ways we can approach this problem and I'll be showing you both. So, unahin natin yung mas madali. So, diba, the formula for any hemispherical cap, we know that that's equal to V is equal to pi h squared over 3, and then we multiply this with the thrice the radius minus h, wherein yung h niya is yung height niya mula dun sa bottom portion. So, kung nasa cap siya, meaning nasa taas siya na portion, and then meron tayong volume dito. So, it's basically kung saan yung kung saan nakasituate yung parang pinaka-weight ng ating volume up to the highest point dun sa level ng surface of water. So, yun yung ating height. Now, just to show you a quick understanding on how this volume works. So, we know that if this h umabot na siya dun sa highest level, which is half of the sphere, we know that this h would be equal to r, and then that in that case, if this h is equal to r, we have pi r squared over 3 right here, and then 3r minus r, which gives you 2r. And then we're left with the volume, which is equal to pi, and then times 2r cubed over 3, which gives us the general formula for a hemisphere, for the volume of hemisphere. So, that's practically how it went in this equation. So we'll be using this equation to find the height of our or the change in the level of the fluid. So we will implicitly differentiate this expression. So we have dv over dt para makita natin kung ano ba yung kailangan natin ng mga expression. So I'll be factoring out yung constant, and then I'll use product rule right here. So we have h squared times, because 3r is constant, the radius is constant. Ito yung parang capacity mismo ng hemisphere natin. So that will be 0, and then I'm left with the derivative of negative h. So that's negative dh over dt, and then plus we have 3r minus h, and then the derivative of h squared is simply 2h, and then dh over dt. Okay, so this is basically the expression, and then we know very well na yung h natin, since we have h is equal to 5 inches, and we know from this expression na yung r natin is simply half of the diameter, and that is typically 10 inch. So 10 inches. So we already have all the necessary values for this expression. So therefore 3, because yun yung dv over dt natin, ito siya. So 3 inches per second is equal to pi over 3 times h squared. So again, h is 5. So lahat naman is naka-inch. So di ko na siya isusulat kasi consistent naman tayo with the units. Okay? And then plus 3 times 10 minus 5, and then we have 2 times 5, and then dh over dt. So we're looking for dh over dt. I'll just be using shift solve to find this dh over dt right here. Okay, so, and by the way, dh over dt is actually draining, or I mean it is decreasing. So when you get an answer that is positive, you could just write negative, that will mean that it is decreasing. But in this case, when you represent dH over dt, mula dito pa lang sa expression to, you don't have to write negative in this case because we're doing that when we already have a value of our dH over dt. But when we're looking for something for the expression or the value itself for any decreasing variable, you should not be making it negative na dito. Kasi kung mapansin nyo nga ulit, 'di ba, before meron tayong halimbawa, yung ating dv over dt. Ginawa natin siyang negative yung yung value dito. Pero yung mismong expression na dv over dt, 'di ba, hindi naman siya yung negative. Kasi usually kasi ito yung positive and then yung equivalent niya yung nagne-negative. So, just stick with the positive value here and then just find dH over dt. So, upon computing for that, the answer is equal to 0.0127. That will be inches or inch per second. Okay? So, this is our answer. Medyo simple lang siyang isolve once na alam natin yung formula. Kasi kung hindi natin alam, medyo matagal yan. And it will be different kung ginamit nyo is hemisphere. Kasi diba, function lang siya ng R. Hindi siya nagiging function ng height natin kasi pag kasi ginawa mo yung volume ng hemisphere, it just means na you're considering a full volume of the basin, which is incorrect in that scenario. Okay, so the other equation that we can use for this is the one that represents it in terms of the base length and then yung kanyang height from the bottom. So that is simply equal to pi h over 6, and then this is multiplied with 3a squared plus h squared. Okay, so yun yung pinagkaiba ng dalawang equation. So ito yung isa and then ito yung isa. Now, what is a? So going back with this figure, a is the distance from the center to the boundary of that basin. So if you have a center right here, this from the center going to that boundary, so yun yung ating A. Okay? So, how do we determine A with respect to H? Kasi ano ba yung maging equation natin from that? So, kung mapansin nyo itong figure natin, alam ko nakikita nyo yung portion na yun and then meron dito, no? So, baka isipin nyo, gagawa na lang ako ng triangle dito and then I'll use Pythagorean theorem, but that is incorrect. So, I'll just tell you something about this. That is incorrect because kung mapapansin nyo, di lahat ng pagkakataon is ginagamit natin yung Pythagorean theorem na basta mag-drawing lang kayo ng yun nga, yung drawing lang kayo dyan ng triangle. So, if we have something like this sa hemisphere, ulitin natin, no? So, wag nyo nang isipin yung nasa taas na portion nito. So, ito yung parang full level niya, but as it decreases, kung mapapansin nyo naman, dito sa oval na to, we could just imagine this decreasing. So, basically, mag-start siya dito and then maging ganyan na lang siya. And then, bababa pa siya ng bababa up to the point na sobrang baba na yung level ng fluid niya. So, alam ko naman na nagigets yung sinasabi ko dito. So, ano ba yung relationship na pwede nating makuha dito with regard dun sa ating height? Now, we know very well that this is the radius of our hemisphere. We know that this is R. Okay? And whichever level of fluid that we select, that height would always be, that H would always be the height of that fluid from the bottom. Okay? So, in this case, if I would be choosing, for example, this one. Okay? So, this is our level of fluid. So, yun yung ating concern. Let's just delete this. Okay? So, yun yung aking concern. Now, if I would be drawing a line going from the center of this hemisphere or dun sa pinaka-top niya, going to this intersection. So, ito yung dulo-dulo ng ating level of fluid and then yung boundary ng ating hemisphere. Can you see it from here na this radius is actually equal to this one? Because if you have any circle or hemisphere, when you have a radius and then you try to connect that with any point at the circle, you will know that that is also the radius. And in the same way na if I connect this one, that should also be equal to the radius as well as this one. Medyo hindi lang nyo napapansin dyan na magkapantay sila kasi medyo hindi perfect yung circle. But if it is, you will know that this is also equal to the radius itself. So we could just say that this is also r, capital R. And knowing this dimension is A based on our figure right here. So from this, doon natin makukuha yung ating Pythagorean theorem. Not on the bottom side of this portion, but on the upper side. So we can say, therefore, that we have a squared, that's the longer leg, and then the shorter leg would be simply r minus the level of the fluid. So that's r minus h squared, and that is equal to the radius itself. Okay, so this is our general expression we've derived from the figure. Okay, and then to find all the relationships, we can substitute for the value of r and h, and then you'll be able to get a. So if h is equal to 5 and r is equal to 10, so we have 10 minus 5 here squared, and then this one is 10 squared, we know for sure that a at this level would give us the square root of 75. Okay, and that's actually equal to 5 square root of 3. So basically meron na tayong a. Now the next problem would be that if we would implicitly differentiate this expression, ito, di ba we know that this is dv over dt, and then we factor out this constants pi over 6, and then we apply product rule. We know that this will be h times, we have 6a dA over dt plus 2h dH over dt, and then we add, because it's a product rule, 3a squared plus h squared, and then we have dH over dt, kasi yun yung parang h na lang natin dyan. Okay, so we already have this h, alam na naman natin yan, but yung a nakuha natin siya based dito sa ating expression. But how about this dA over dt? Because we need to express this in terms of dH over dt as well. So babalik ulit tayo dito sa expression na to. We know that we can actually differentiate that or implicitly differentiate that with respect to dt or t. So doing that, we will get 2a and then dA over dt. Oops. So we have 2a dA over dt, and then we have plus, we know that this r is a constant, so 2 and then r minus h, and now we're left with negative dH over dt, so multiplied with that, and then that is equal to 0 because r squared is a constant. Now I'll just be copying this, and then I'll be pasting it somewhere here para makita nyo siya. So this is obtained from this general expression of Pythagorean theorem, and then we know very well na yun nga, magsi-0 yung ating r because siya ay constant. So we can cancel 2 here kasi siya ay constant din, kasi magsi-0 naman to. So we're now left with dA over dt. I'll be transposing this to the right. This is negative d, so I have r minus h and then dH over dt divided by a. And plugging on the values that we have already obtained, kasi yung r natin is 10, h is 5, and then we have dH over dt right here, and then a, kung natandaan nyo, is the square root of 75, so that's square root of 75. So therefore, we know that dA over dt is actually equal to 5 over square root of 75, and then dH over dt. Okay, so that is our dA. So now we can plug in that value to this general expression. So I think I should have done this later pala. So yan, para mas maganda yung flow ng ating solution. Okay, so diba we usually, kapag meron tayong inintroduce na ibang variable, we usually take the value at that point or at that condition, and then we try to find an expression wherein the relationship that with respect to time would give us a function of the other variable with respect to time. Kaya meron tayong dA and then dH right here. Basta ito yung ating easiest solution, but this is another solution that you can do using this equation naman. So ang nawala dito is yung ating radius na constant. Okay, so we proceed with substitution. So we know that dv over dt is 3, and then let's use green. So we know that this is 3, and then we have pi over 6, and then h is 5, and then 6, we know that a is actually equal to square root of 75, so that's square root of 75, and then times, this is I think 5 over square root of 75, and then dh over dt, and then plus 2 times 5, and then dh over dt, closed, and then plus, we have 3a squared, so that's 3, and a squared is 75 since it's square root of 75, so plus 5 squared, and then that's dh over dt. Okay, and we close that with the bracket. So you'll be able to get dh over dt, and that is also equal to 0.017, I mean 0.0127 inch per second. So using that formula, we also obtained the same answer. Okay, so this is how you solve for such kind of problem. It always depends on your general equation that you'll be using, but you should be getting the same answer, and this solution is quite simple. We didn't have to find any other relationship with respect to the illustration, but in this case, we need to, because the general expression that we need is somehow expressed in terms of a and h, wherein a is the distance from the center to the other point on the hemisphere, which is just horizontally, which is at the right or at the left at that horizontal level of the fluid. Okay, so I hope mas nag-gets nyo tong discussion na to with this example.